Hello and welcome to our STEAM project number 13 featuring the Raspberry Pi Pico and MicroPython. This lesson is part of our Sherpa level series, designed for the somewhat experienced STEAM teacher. Today, we imagine ourselves in the cockpit of a race car, full of tension watching the green light to switch on and hit the accelerator. The pilot with the fastest reaction gets into pole position and has the highest chance to win the race. My name is Peter, I am the founder of Educomondo and a certified STEM instructor. The goal of today is to develop a program where we measure the reaction speed of a person. We do that by measuring the time between switching on an LED and pushing a button. So we will see how to break down a project into functions, also referred to as helper functions. We will rehearse how to integrate push buttons in a project and use the pull-up and pull-down resistors. We will include some program feedback and error handling, create a final scorecard with ranking based on the best average reaction, and most importantly, we'll make sure that your class works as a team to find solutions, help each other, and present their project in a clear way. The breadboard project is quite simple. We need a breadboard with a Raspberry Pi Pico, a green LED, a push button, and maybe a quick question in between. Can you tell if this is a pull-up or a pull-down configuration? A resistor of around 220 ohm for the LED and one of 10,000 ohm for the push button, and a couple of jumper wires. Because we want to add quite a number of functionality in our program, it's advisable to think about the structure of our program and the helper functions we will create. This is a great interactive moment with your students to check whether they are able to create a logical outline and start to understand the different blocks of code that will be needed. So let's break down the project into digestible parts or functions. Basically, there will be three parts in this game. First, we will do the necessary library imports and hardware setup for the push button and the LED. Secondly, we will create 5 helper functions. The first one will ask for the number of players, the second one will gather more information about the players, for instance their names, and we will also create a nested dictionary where we will add additional information of the players, for instance their reaction time, the score, and the total score. The third function will look for the reaction time between the green LED switching on and the time that is passing between that action and pressing the button. The fourth part is actually going to be the core game loop. And we will end by creating the scoreboard. The third main part will actually be the main program, very simply bringing all of the helper functions together. Without further ado, let's go to our live recording. Welcome to our live session, and as you can see, we are already in the Thonny environment and the program is already there, because this time we're going to approach this slightly differently. We are not going to have a code along, but more of a follow along. Now, I want you to keep in mind what we have shown previously, which are the 3 main areas and the 5 different helper functions. So you will recognize them very, very clearly into our program. We will start with our imports of our libraries, the machine, the utime, and the random. And in this part, this is where we are setting up our hardware. And this already is our first helper function. And the purpose of this helper function is to prompt the user for an integer, and an integer being the number of players that will start with this game. And because we want to capture possible errors in the input, for instance, a symbol or a letter, we really want to have an integer number, we use a loop to keep asking for input until a valid integer is entered. And to do that, we are using a try except block, as we call it, a try except block to handle potential value errors if the users enter a non-numeric value. So this is going to be a loop until the user is going to provide us with an integer number. The second one is getting more information on the players. So this function is going to take the number of players, which we just received from the players, and it's going to take that number as input. It's going to create an empty dictionary, and we call it players. Here we call it players, and it's an empty dictionary. And this is going to be used to store the player information. And we get that player information by creating a for loop, which is going to iterate the number of players' time to get the details of each player. So it's going to prompt the name of the player on one hand, and it's going to store that as the key in the player's dictionary. And as you can see here, it's going to create a nested dictionary for each player containing additional information like score, the total score, and the reaction time. And of course, the reaction time is still open because that is exactly what we are going to capture. And we capture that in the next part of our program, in the next function, the next helper function. And what is this going to do? Well, the main function, it's going to simulate the reaction time between the LED lighting up and pressing the button. So it generates a random number between 0 and 5 seconds, milliseconds, 5,000 milliseconds, and this random number is the input for a delay. When that delay is over, the LED value is set to 1, so our green LED is going to be switched on, and this is the start of the time capturing. So this is where the utime.ticks in milliseconds is going to start ticking. The clock is ticking. It's the start of the program. Now, it records that session, and it uses a loop, a while loop, to continuously check whether the state of the button is still 0. So this loop doesn't perform any action. It's indicated by pass, and waits for the button to be pressed, because when we press the button value is no longer going to be the same as 0. It's going to be different than 0. And the loop will exit at that moment, and at the same time it's going to capture the end time. Very important, because we have a start time and an end time, and at this very moment we also are going to make sure that the LED or the LED is going to be switched off again by setting the value to 0. The return of this function is going to be the result of the end time minus the start time. So the difference between the ending and the starting time, which is representing what we really wanted to capture. It is the reaction time. Now we are going into what I would call the core of the game. Because this is where really the game is going to get started. This is where we start to play the game. It runs continuously through this while true loop till the players decide to stop. So if play again is going to be a 0, then we will stop this particular while loop. Because we have a for, so while true and then for, it iterates through the names of those of the players, so it's going to iterate through each player in the dictionary using this particular for loop. And for each player, it's going to do a couple of actions here. First of all, it's going to print your name, and it's going to prompt you that it's your turn to play. It calls the reaction time function. So this is very important, that in this line we are making use of another function. So in this function we are embedding and using another function to measure the player's reaction time. It's going to update the player's data and individual scores. This score is going to be set to the minimum of the current reaction time and the previous score, meaning that only the best reaction time is kept in this particular field. We're also going to add the reaction time to get a total, so that we have a total score, and it's going to append, using this append, it's going to append the score to the reaction time to a list of the player's reaction times, and it's going to print all of this in milliseconds as a feedback mechanism towards that player. And then finally, as we've just seen, it's going to ask whether you want to play again or whether you want to stop this game. The next helper function is where we are going to do the mechanism of capturing all the data and sorting all of the data. So it's going to be the display scoreboard, as we called it, as the name of the function. And the function displays the final scoreboard after the game is ending. It's going to first sort the player's dictionary by total score using sorted. So this it's going to go through all of the results, and then it's going to sort it. And then it's going to once again it's going to iterate through all of the players, through that sorted list of players, and for each player it's going to calculate the average time by summing up the reaction times and then dividing it by the number of reactions. It's going to find the fastest time, the fastest reaction time from the list of reaction times, and it's going to print the name of the players, the total score, the average reaction time, formatted to two digital comma behind the comma, two decimal places, and it's also going to show the fastest reaction time of that particular player. And I haven't really talked about this because we have seen it in our previous lesson, but here again I'm making use of the lambda, the throwaway function, in order to sort by total score. And this is then going to be our third main part, and as you can see, what we need to do now is to just in the right sequence call the different helper functions, and that is going to drive the game. It's going to drive the sequence of the game. So the number of players, it's going to call this integer function, and so it's the first thing. It's going to call the number of players. Then the players themselves, it's going to get more information about the players. Then we're going to have this dictionary, so of play game, where all of the elements of the game logic are going to be represented, and then it starts with a scoreboard. So in essence, this main program is getting the number of players, creating a dictionary to store player information, starting the game loop, and display the final scorecard. So I hope you were able to see the logic and definitely also the representation of this particular area. And this time I'm going to see if everything works. So we are going to upload the program, run the program, and as you can see, the first thing that is being asked is the number of players. So let me say we have 3 players, and one is a tiger, one is cat, and one is Mr. or Mrs. Dog. You can see it asks for tiger turn, and it was a little bit late because you can already see that the green light was on. So play again. Yes, we want to play again. And yes, this was for dog. We will continue to play. And those are my scores, or the scores of the 3 players. Let us do another one. We want to, and tiger was just a little bit too late. Now it's the next one. Dog. Hey, this is faster. So we will play again. Cat. And the green light. Yes, the green light is on. And let us do one more round. Now it's dog. And we have captured all of the reaction times. I'm now going to stop the game by just typing no. And as you can see, the scoreboard shows us that sorted by the average reaction time, so the fastest action time, average reaction time, is cat, then dog, and then tiger. So cat has 334.67 milliseconds, dog 362.67 milliseconds, and so on. And tiger was a little bit slower because, of course, I was quite late at the very beginning of the game. As you can see, it works quite well. I hope it works well for you too. and we'll see each other in the remainder of the lesson. Here we are back, and I hope the program has also worked for you and your classroom. If not, well, you know it and your students know it. This is no time to panic, but to conduct some critical review of the code and checking both error messages on the physical project. So don't panic. This is a great game that can be used to engage the whole classroom. For instance, from each group, the fastest players play against one another, the second fastest against one another, and so on, till you have the top 3 of the best race pilots in your class. That's it for lesson 13. I am confident that you and your class had a lot of fun with it. Now that we have covered some game development basics, let's move on to another topic, data logging. In Project 14, we will explore how we can log data and create datasets that we can export to Excel or other programs for further analytics. I look forward to seeing you again. Bye bye for now.